Okay, so we have a question here that maybe we'll address, but just gave you a hint. Okay, on this one, we have a question that involves y prime equals f of ty. And we want to know regions on which, the largest region on which you could get a solution. And that comes down to the largest region on which this function is continuous. Okay? Why is this? Well, let's see why. That's the rule. That's what the theorem says. But there's a reason for it, and you'll never remember the theorem unless you remember the reason. Maybe you'll remember the theorem, but you won't understand it unless you know the reason. Okay? You might be able to apply it, but it's better to understand it because then you remember it better. Okay, so you got y prime, you got an equation. Now you got to rearrange an equation, but you had an equation that you easily rearranged when I told you, well, rearrange it to this form, right? When you asked the question. Okay, so you easily rearranged it. That was good. I asked for it as continuous. And you said, well, got to be, can't be, t can't be negative, so it's going to take everything to the left of the y-axis, right? And it's not going to be there. Okay? And then cosine y can't be 0. Well, where's cosine y equals 0? So, okay, well, you got t greater than or equal to 0, and cosine y not equal to 0. And you're continuous if these conditions hold, right? And we quickly get that to this. It wasn't all that quick, but you got it. You understood it. You told, well, y can't be pi over 2. It can't be 3 pi over 2. Now you wanted to stop there, but you know, y values can go way beyond 2 pi, right? So it really comes down to y equals pi over 2 plus n pi, where the cosine is 0, okay? So the function is discontinuous where y equals pi over 2 plus n pi. And we'll say that's this line, and here is the line y equals pi over 2 plus n plus 1 pi. Okay? Now, if we take a point in this region and try to do an approximation, what do? Well, we take the coordinates of that point, we plug into here, and there's your slope. Now, that doesn't work so well if cosine of y happens to be 0, right? It doesn't work at all if t is less than 0 either. Okay, so you can't do it. But you maybe want to ask what happens as you approach these positions of discontinuity, because that's where things break down, as we saw the very first day. Okay, so we estimate our slope. Now the slope will be positive if n is an odd number. No, but yeah. Now if n is an even number, this will be positive, right? Because that would be like pi over 2, and then an odd number, or an even number for n would give you an odd multiple of pi. Here it would give you like 3 pi over 2. So it's going to be between an odd, well, you know, without writing that down, you understand what I'm saying. And now if n was an even number, then this would be like a 3 pi over 2 or some coterminal angle with that, okay? And this would be like 5 pi over 2. So depending on whether n is even or odd, your slope might be positive or negative here. Okay? So, and actually where I got that, the slope is going to be pretty close to 0, but we'll say, okay, let's just say it's positive. So it goes out. Okay? And then we recalculate the slope, and it goes a little more positive. We recalculate the slope. Okay? Well, pretty soon we're going to run into this point where the slope is obviously going to approach infinity, right? So we might be able to approach this point, but we can't cross it because we have a discontinuity, and all of a sudden the slope takes the opposite sign. Okay, so if you're approaching from this side, this slope is going to do this sort of thing, and it's not going to be continuous, it's not going to be continuously differentiable, okay? So basically the line is, and what everything I said there isn't quite right because I'm not totally certain about it, it's been spontaneous, but what you're going to find is that you have a different function here than you have here, different types of functions, okay, depending on where you are in the interval. And you can't expect continuity. Certainly not continuity of the derivative, okay? So your projected solution stops at either of these lines.
For the initial condition given?
Yeah, well, the initial condition basically just gives you a point somewhere in the plane. It's going to be between two lines. If it's on a line, well, the equation isn't even defined, okay? And of course, as you approach t equals 0, unless y is also getting close to one of these lines, you also approach a 0 slope, which means that at any one of these points, you're coming off of this point, your solution curve is always going to be level here, okay? Then you're going to start, it's going to change because t is going to take a non-zero value, and you got to take the cosine of y into account. Make sense? Okay. And actually, since you're dividing by cosine of y, well, I'm not going to go there. You can do a finite element analysis on this function with some simple interval and see what the solutions look like. Or you can easily solve the equation. It's separable. You're going to have cosine of y dy equals square root of t dt. Okay? So you're going to get a negative sine of y. K equals a 3/2 power of t plus a constant.
Wouldn't that be positive sign?
Yeah, it's a positive sign. I don't, you say things so. Okay? So I'm glad I told you to keep checking on me. So, very good. Okay? I was just testing you. Yeah, we know better. Okay? Make sense? So, t is going to be like the inverse cosine of a 3/2, or y is going to be an inverse cosine of 3/2, 2/3 t to the 3/2 plus a constant. And then you get to deal with that. Okay? But you can at least understand from the behavior of the inverse cosine function what these curves might look like. Because it's a very easy equation to solve. Okay? Make sense? Okay. Now the other equation, it's the same idea. You just look at where these things are not continuous, and that partitions the plane into regions in which you can project a solution.
So this one had the initial condition y of pi equals 1.
It said y what?
Y of pi.
Y of pi is 1.
Yeah.
Okay, so, that means t equals pi, right? So here's your t-axis somewhere, right? And here's pi. Right? And where's 1? Well, it's between 0 and pi, or well, between negative pi over 2 and positive pi over 2, right? Okay, and I did draw my t-axis. Well, yeah, I drew it fairly well, because it's going to be halfway between negative pi over 2 and positive pi over 2. So I just lucked out and drawed it in the right place. Okay, so t equals 1, well, pi over 2 is like 1.57, right? So that would give you point here. But the question doesn't ask you to find the solution within this interval. It just says that your interval the solution is guaranteed. That's what the theorem says. You should read your book and read the theorem, even read the proof of the theorem. Not that hard to understand. It's just saying basically the same thing that you understand if you understand how to do a numerical solution. Okay? Your solution is guaranteed. And you can do the region in many ways. I'll just use set builder notation. It's a region TY, okay? Such that T is greater than or equal to 0, and negative pi over 2 is very equal to pi over 2. Okay? Now if it said y of pi equals 493.7, you'd have to figure out what multiples of, what values of n would, for what values of n that number would fall between here and here. But that's simple inequalities. Okay?